Hi, I'm Mike Barsotti. I'm the Director of Water Quality and Production here at Champlain Water District in South Burlington, Vermont. I welcome you today to our mini tour of our water treatment facility, and where we're going to talk about aspects of water treatment, water production, and also our source water. Thanks for coming by, and here we go. We are located in South Burlington, Vermont. We serve 75,000 people, and we are the largest water supplier in Vermont. So for all the information that you're going to see today, there's more detailed information on our website that can be found, and it's champlainwater.org, and that's where you're going to get detailed information about the district and our practices, and also learn about our receipt of the 20-year Excellence in Water Treatment Award. We're very, very proud of that. Now, I have received questions from students regarding where drinking water comes from and how it's produced. So I'm going to answer those questions, and then we're going to have some of the people some of our professionals here at Champlain Water District show you some of the processes here at the treatment facility and also down at the lake. So one of the questions that I received from students is, where is our water from? Okay, and you can see the picture there in front of you, and our water is from the deep underwater canyon of Shelburne Bay. Shelburne Bay holds 33 billion gallons of water, and it is part of Lake Champlain, which holds 68 trillion gallons of water. This is a very high quality source, and Jim DeSorda is going to discuss this aspect of our supply later on. Okay, so the second question I get is, how is water treated and made into drinking water? So you see right there in front of you is what we call a flow schematic, and that's from our water quality report. Now that's just a fancy name for just showing how the water is treated. You can see that the water basically starts out from left to right. The water starts out from our deep underwater canyon source in Shelburne Bay, very high quality source. We go through pre-oxidation into lake water storage, where the water then flows into our absorption clarifiers, through our deep bed multimedia filtration, through primary disinfection, secondary disinfection. Again, I'm going from left to right across the screen, into storage, and then to everybody's houses. So that's how water gets to you through the treatment process. And we will have Travis Sheldon is going to discuss this aspect of our supply later on. This is a more detailed schematic than the one we just showed previously. You can see here that going from left to right, it shows that we have 2 manifolded intakes in Shelburne Bay, our supply of water, that we have 6 pumps at our Edward Blake Lake Water Pump Station, and then the water flows into 2 500,000 gallon storage tanks up here at our treatment facility. It shows the water flowing in to the treatment facility. It shows 3 adsorption clarifiers. It shows 8 deep bed filters. It then shows the water going into our filtered water tanks. We have 2 of them, each hold 1 million gallons of water apiece for a total of 2 million gallons. The next question I received was, what are water residuals? And the answer to this question is that the residual is what results from the treatment process after we've removed the phytoplankton and little pieces of clay and sand from the lake. And this is a material that's very useful in controlling phosphorus. And there have been several pilot projects and full-scale studies that show that a very, very high removal of phosphorus using this material, and this has been used in applications such as home septic systems, agricultural runoff, and stormwater runoff. And it's also used as a compost amendment. Ariel Smith will show this aspect of our water supply later. The next question I received is, what is water used for? The district's water is used throughout our service area, north to Milton, Vermont, east to the Jericho Underhill Range facility, and south to Shelburne, Vermont. It's used as potable, what we call potable water supply, and that means drinking water, shower, bathing water, water that's used for personal hygiene, such as hand washing, also in food and beverage production. And also it is used for fire protection in our member municipalities. We produce an average of 9.4 million gallons of water a day, and we serve that water into 19 storage tanks located throughout our service area. And those storage tanks range in size from 2 million gallons and a little smaller within the system. And storage tanks and pumping provide water pressure for all of our important water users and our customers. The next question I received is, how is all of this managed and controlled? Well, we have something that's called a SCADA system, and that stands for Supervisory Control and Data Acquisition System. That's where the SCADA, SCADA, comes from. And I think the best way to describe this is that I like to say this is radios that talk to computers that then control devices and infrastructure throughout the county. And of course we're talking Chittenden County, Vermont here. There's data gathering that goes on, as well as data management and display. The control functions that this SCADA system performs are very important. Commands are changed into radio signals, and then the radio signals are received and they activate infrastructure, and then the infrastructure moves and it is controlled at our control center. Monitoring devices gather data, and then that is translated to radio waves and then converted back to computer signals and displayed in real time. Michelle Cheviot will discuss this aspect of our water supply later on.
Here we are at Red Rocks Park, home to Champlain Water District's Lake Water Pump Station. Around 10 million gallons of water is pumped from here each day. This is the beginning of the treatment process. Our intake is located in the Shelburne Bay, about a half a mile from the pump station and 75 feet below the surface of the lake. The intake pipe is split at the end into two sections. Each week, plankton nets are used to gather concentrated samples of phytoplankton from each of the intakes. These samples are viewed and photographed under a microscope. The sampling is an added protection to ensure the absence of cyanobacteria, also known as blue-green algae. It's also useful in understanding how different varieties and concentrations of plankton affect the filters and the treatment process.
Hello, my name is Travis. I'm the lead treatment transmission specialist here at Champlain Water District, and I just wanted to take a few minutes to show you around some of our filtration process. As you've probably seen from some of the other slides, water's pumped out of Shelburne Bay and up into some storage tanks in the front of the plant, where it gravity feeds through the basement of the plant and into one of 3 absorption clarifiers. These clarifiers remove about 60% of the particulate that's found in the raw water as it enters the plant. After the water passes through those clarifiers, it's going to land on top of one of 8 filters that look like these. These are a mixed media filter. They consist of layers of anthracite, garnet, sand, and gravel. Water passes in through the top, and it's allowed to filter through the media and out through the bottom of the filter. Any one of these filters at any given time are generally filtering between 1 or a little over 2 mgd at a time. These filters generally run for maybe 60 to 70 hours or until some other metrics involved let the operator know that it's time to run a backwash. The backwash process consists of introducing some air to the bottom of the filter to loosen the media, and then pushing water up backwards through the media and into a trough, which then flows out into a settling lagoon behind the plant. We have a filter right now that's in the process of a backwash. So right now filter's flowing up through this filter, up into the trough, and then out into a settling lagoon. The filter that flows through, the water that flows through the filter when it's online passes through the bottom of the filter into a wet well and then into a contact time tank here at the plant. That water then eventually gets pumped out into the system.
Hey everyone, it's Joel, and what we have here is a schematic of our distribution system. Now let me explain a little bit about what we're looking at here. The schematic is not based on any kind of geographic scale, but instead it's based solely on elevation. Now as we can see, there are different lines going all over the place. Those are our water mains. They carry the water from point A to point B. The green circles that are kind of scattered all over the place here, those are our serve systems, what we call our serve systems. Essentially they are different pressure zones within our distribution system. And these blue tank looking shapes are our storage tanks, as you might have guessed. So let's talk a little bit about the tanks themselves. If I were to ask you, what's the purpose of having water storage tanks? Well, your answer might be something along the lines of, well, it allows you to store more water. And you are not wrong about that. That is definitely one of the purposes of having several water storage tanks placed throughout the distribution system. Now, keeping these tanks full of water allows the entire system to stay pressurized. Why is this important? Without pressure, no one gets water. In order for any water to make it to your house, out your faucet, there needs to be pressure in the lines. Keeping these tanks at sufficient water levels enables that pressure to remain somewhat constant in different areas, sufficient enough to get water to where it has to go. The bottom line is, if there's no pressure, there's no water. So it's very important to keep the water levels at appropriate levels in these tanks. It's important to keep this whole system pressurized, not only for households to get their water, but it helps with fire suppression as well. Fire hydrants out in the system, they need to stay pressurized at a certain pressure in order to work effectively. Keeping the tanks at certain heights will help along with the pressure of the water coming from the plant. It's important to have sufficient water in the tanks to provide that pressure for extended periods of time if necessary, depending on the size of the fire or the amount of water needed. Now, another purpose of having these tanks out in the system and us being able to monitor them here at the plant is they can act as an early warning system for us. If we were to look down here at this screen, this shows each one of our tanks, their height, their current height, the rate of change currently, as well as their low and high limits. If we see anything out of the ordinary, say one of the tanks starts dropping 6 feet an hour, that'll key us in onto, okay, something's wrong out there. We're losing a lot of water for some reason. This could be because of a fire, this could be because of a main break. Whatever the case may be, we can see it quickly, and we can kind of try and diagnose the problem, investigate, and try and get ahead of the problem as much as possible. Now let me explain a little bit more specifically on the water level in the tank in relation to you getting water in your house out of your faucet. Now let's take this tall tank here. This tank is located in South Burlington. If you've driven down the interstate, there's a good chance you may have seen it. If we look closely at it, probably can't see the numbers, but if you look, the bottom number there is 430. That is 430 feet above sea level. So that is the height above sea level at the base of the tank. Top number is 558 feet above sea level. So anywhere in that range of heights is where that water could be. Now that middle number is 505 feet. If your household is at that height, then that means you are not going to get any water unless the height in that tank is 505 feet or higher. And that goes for all of the other tanks as well. There are engineers out there who determined the heights of those tanks and established that those are appropriate heights to supply water to all residents in that area.
Hello everyone, my name is Ariel. Hi. I'm a treatment transmission specialist here at Champlain Water District. Just wanted to begin here with a tour of our lake water tanks. Each tank is 500,000 gallons, totaling 1 million gallons of water that then goes into the plant and through our plant. Water travels from these lake water tanks and through the building, going through the clarifiers and then through the filters. And from the filters it gets pumped out to these finished water tanks. We have 2 of those, 1 million gallons each, totaling 2 million gallons. And as we wash the clarifiers and the filters, the water comes out here to our settling lagoons. With this water from the clarifiers and the filters, there are residuals, which are the particles left over, and they flow through these yellow curtains from one lagoon to the other. So once the water has filtered through these lagoons, it goes out into a brook and leaves all of the residual material behind, and then once a year we take it and we pump it into these big blue buildings. And when we pump it into those buildings, we pump it over its 3% solids, and then as it settles naturally it's 10% solids. These are the freeze-dry beds that stay throughout the winter, and then after the winter it's 90% solids. So what can be done with this? It can be used in agricultural runoff as filtering media, and it removes phosphorus from the runoff. It can also be used in septic tanks, and it can be used as compost as it's really high in nutrients. And thanks for your visit to Champlain Water.
Hi everybody, welcome to Champlain Water District's operations room. This is the midnight shift. Pretty quiet here. This is where we get to monitor and control the water that we're processing and distributing. In our operations room, we've got some of the control panels that help to control the filters, where we can manually adjust if necessary. We've also got this little control panel that helps us to monitor chemical feeds. It's important that we are able to see what's being fed out, how things are going in the system. This one specifically has to do with one of the chlorination pumps. It's touchscreen, very easy to operate, allows us to adjust remotely, makes it a little bit easier than having to run out to those control rooms every time we need to make an adjustment. From in here we can monitor our flows. This information is recorded regularly, as well as tank levels. Our control panel to monitor which main system pumps are being run currently. And like I said, this is the midnight shift, so I don't really see a lot of people normally. Our board helps me specifically with knowing what's going on, what our target goals are, what we should be doing for the night. Notice we do have quite a few computer control panels up and running. In addition to recording all of this data and monitoring it electronically, we are also responsible for making sure that it gets put down on paper. A backup system per se helps the operator focus in on some of the things that are most important. At this point, I'm about to start a wash sequence for one of our filters. This panel here shows all of the filters that we have running in the system. Using a control log like this one down here helps me determine which filter is up next for washing. And it is fairly easy to use system, using the mouse, figuring out which one you want to put into wash, and then going with that. Alright, so I was able to get one of our filters started in wash. With the computer program, I can do a split screen. And on the right side, I've got the specific filter that is being washed up so I can monitor it, as well as keep an eye on what's going on with the rest of the filters and the flow rates. While this gets started, I am going to go start some water quality lab work. Connected to our operations room is a small lab that allows us to verify the information that we are being given through the various remote systems that monitor the water for the chemical feeds. And for the next half hour or so, I'm going to be keeping an eye on our filter that's in wash while I perform some analysis.
So as I said earlier, my name's Mike Barsotti. I'm the Director of Water Quality and Production here at Champlain Water District. And this has been the Champlain Water District's presentation of how we treat water and teaching you something about the whole water production process. Champlain Water District's mission is to produce safe, high-quality water from source to tap. We do this by working 24 hours a day, 7 days a week, 365 days a year to optimize our supply functions. And again, to find out all the information that you want on this very interesting subject, go to champlainwater.org and just take a look through the website. We appreciate you coming by and learning about water with us today. Thank you.